Welcome back, everybody. We're going to start with the next session. Our next speaker is Tom Coffeen. Tom is the Chief IPv6 Evangelist at Infoblox. At Infoblox, Tom is focused on the articulation of effective IPv6 adoption strategies, as well as working with customers, potential customers, and the public media. Prior to joining Infoblox, Tom was the VP of Network Architecture at the global CDN Limelight Networks, where he led their deployment of IPv6.
Okay, thanks for the introduction, Augie. Hello, everyone. Good morning. I'm Tom Coffeen with Infoblox, as Augie just mentioned. Today I'm going to talk about IPv6 address planning, a subject that I get pretty geeked out on and pretty excited about. As Augie mentioned, at Infoblox we're trying to figure out where IPv6 fits into our existing customer base, which is really more enterprise focused for the most part. We do have service provider customers, but as we've seen in Jeff's presentation, they're further along on the adoption curve for IPv6. With enterprises, we're not so clear as to where they're at. We don't necessarily have great data. We see some operational issues filtering up around DHCPv6 finally, suggesting that there's some internal adoption of IPv6 happening at certain enterprises. So that's encouraging. If there are any enterprise folks here today, I'd love to hear what your operational experiences are. Not just related to what Infoblox deals with, which is DDI, DNS, DHCP, and IP address management, but we know IPv6 security in the enterprise environment is a pretty critical topic these days, and I'd love to hear more. So, somewhat tongue-in-cheek, the title of the presentation, 30 Minutes to Perfect Abs and an IPv6 Addressing Plan. I want to show that when it comes to putting together a basic IPv6 addressing plan, there's a handful of simple principles that if you apply them and iterate them, you can actually come up with an address plan pretty quickly and effectively that may serve your enterprise, your organization, far into the future in a way that you probably wouldn't anticipate if you're thinking about the complexity of IPv6 versus IPv4, or if you're thinking in terms of, hey, how we've had to build address plans in IPv4 and the various methods that we've had to use. You'd be pleasantly surprised to learn that it's much easier to do in the domain of IPv6. So we'll start with a few key principles around what we need to know when we start thinking about what to do with an IPv6 addressing plan for our organization, our enterprise. And the first among these, and it's probably the most critical, and it's the one that we could sort of rush past if we're not really aware of the way in which IPv6 address plans have typically been iterated for folks that have put them together and used them in their networks. Determining the initial allocation size is probably one of the first most important steps. It actually is the first most important step. And it's based on determining the number of sites that you have within your particular network, within your particular organization. And so we'll get into this concept of what a site is, and it's a very fluid definition that isn't something where we're going to refer to a very fixed idea that's been defined at an engineering level about what constitutes a site. And if we move away from that, then we have to move away from how much space we're going to allocate. So typically we assign a /48. It's a rule of thumb that a /48 can be assigned for a site. And we don't necessarily stick to that in all cases. Depending on the size of the organization, how the network is laid out, you may set aside a /48 for a site. You may set aside less space or more space. We'll get into a little bit of that discussion about what drives that decision. But from this chart, you can see most enterprises receive between a /32 and a /44 of address space for their initial allocation. And the reason why this initial determination of the size of allocation that you get is so critically important for enterprises is that what's happened frequently in the past with enterprises that have been intrepid and gone out and said, hey, we really need to get a handle on this IPv6 thing, and they start thinking about, well, how much space do we need? And they look at the standard allocation size. If you look at a /48, you're talking about 1.2 times 10 to the 24th host addresses, right? Just an astronomically large, basically the amount of the same quantity as there are stars in the universe, right? So And then they start thinking, well, if I've got that much space, a /48, I should really be carving it up into smaller and smaller blocks to address my network, without actually thinking about, well, how many sites do I have in my network? How many, and how do I want to define those sites? So we've seen this happen. It's a sort of unforced error very early in the adoption process for enterprises, where they'll actually get an allocation. They'll get a /48. They'll be like, well, this is more than enough space. But they actually have more than one site for the way their particular network is laid out. So they don't have enough space. And that sounds really strange if you're thinking in terms of IPv4. But if you're assigning a /48 for a site, per site, and you've got more than one site, and you only get a /48, then by definition you don't have enough address space. So somewhere between a 32 and a /44 for your initial allocation. So who defines what a site is? Well, it's the United Nations IPv6 Site Definition Council, UNV6 SDC. Anyone heard of this organization? Not actually a real thing, of course. We're not going to give up our sovereign right to define our IPv6 address plan to some United Nations agency. And tongue-in-cheek, obviously, but the idea here is trying to drive home a larger point about where a site definition comes from, and how we're going to think about defining a site when we start to build our enterprise adoption plan, our addressing plan. So the characteristics of site in an IPv6 are based on a logical construct that works for your particular operational needs, right? So, we're not saying, every location where you have a campus-sized network is a site. That could certainly be the case for your organization. You could say a regional office constitutes a site. If you look at the service provider model over the years, we've had different definitions of sites that service providers have used. All the way from, if I have fixed broadband at home, maybe I'm getting a /56 or a /60 prefix delegation. There have been service providers that have handed out /48s for the home user, which sounds a little strange, right? I mean, I've got a home network with maybe 2 or 3 live hosts on it, maybe 10, and here I'm handing out 1.2 times 10 to the 24th host addresses for that single site. So the idea here is that we don't want to get too hung up on trying to figure out what somebody else thinks a site should be based on the theoretical need to conserve address space, because that's really what's driving it. When we start to get nervous about how we're using IP resources, we're in this fixed crouch from years of having to carve up IPv4 in smaller and smaller subnets using VLSM, and we bring this with us into IPv6, and we want to do the same thing to conserve address space. And so our first temptation will be like, well, I've got all this address space, and I want to make sure that I don't waste it. So a 48 per site sounds too big. I'll assign a /56 per site. But as we'll see, the actual buckets of subnets that we have to play with for addressing a site, if we stick to other concepts in IPv6 address planning that are important, like using the nibble boundary, for instance, which gives us a lot of operational sanity and readability within our network, we don't actually have that much. We don't actually have that much granularity using that nibble boundary, and we have like basically a handful of buckets of certain sizes that we can use to assign to network functions and locations. And as we get into doing that, we'll find that if we haven't given our site enough bits, we're not going to be able to leverage that operational benefit from having IPv6 and having enough space. So another concern with the /48, or another reason why a /48 is sort of an important boundary, and this may or may not affect your organization, it's the smallest routable prefix in IPv6, right? So how you determine what a site is in the context of your own network may or may not be impacted by that. If you have a site that today it's connected to the enterprise network internally and routed to the other sites within your enterprise network, but maybe down the road you think you might want to open that site up to the internet. If you have numbered into a space that's smaller than a /48, you won't be able to do that. So it's critically important for some organizations to keep that in mind as they start to put their plan together. And then if you don't have enough /48s, like if you choose a /48 as the size of allocation you want to use per site, the idea here is that instead of returning to that idea of carving up that /48 to give yourself enough subnets to number into the rest of your network. You go back to the regional internet registry or the ISP and you get a larger allocation. You don't say, well, this is what I got and I'm just going to make the best use of it. The regional internet registries, and I hope we'll hear a little bit about this from Aaron later, they're expecting you to put together an addressing plan that makes operational sense for you. And they're not going to worry if you've put together a plan that has operational logic and you've done a good job of dotting your I's and crossing your T's. They're not going to fuss over the amount of space that you've asked for. They're going to give you the space that you've asked for based on that plan. And if it's a /48 per site, that's perfectly fine. So just as an example, we've got three different, this isn't a particularly technically detailed slide, but three different types of sites that we might see. And I already mentioned before that we've even seen service providers assigning home networks a /48 different times. But so IPv6 Uncle Sam wants you to define your site based on what makes sense for long-term operational viability and not on antiquated notions of conserving IPv4 address space. So we have these buckets then that come out of sticking to the nibble boundary in IPv6. And as we'll see later in the presentation, when we do that, we actually give ourselves some additional legibility in looking at a network prefix that we can use to map into various aspects of the network, whether it's function or location. And this becomes very sort of valuable as a way of creating operational shorthand that we could never really do in IPv4 because we'd always run out of bits. Even with the 10/8 space, you just, it's like, hey, well, let's do this cool thing where we make the second octet the location, and we make the third octet the function. But since we've only got 8 bits to play with in each of those octets, we run out of bits very quickly. We just lose the ability then to map the address plan into the network. We don't have that same problem in IPv6. We have a different problem. We have a problem of having too much space, right? So if we think in terms of the nibble boundary, we get these buckets of subnets that we can play with. And so then when we start thinking about how we're going to carve up the network and how our network is defined, we have to think about those functions or those locations falling into one of these buckets. For the basic inter-site plan, the plan of our IPv6 address plan that deals with creating addressing between sites, we can think of it in these terms where, if we have, in the simplest instance, just counting the number of sites that we have and just figuring out where it fits into this. And of course, the little bookmarklet that got handed out from Aaron shows some different numbers because they're using a 75% utilization threshold. So if we take that first bucket of the /36, that's actually 4,096 subnets per group, which works out to be a little more than 3,000 at the 75% threshold. Well, that would obviously be a very large site. I think for most enterprises, they're going to more comfortably be in that /40 to /44 range, where they have between maybe more than 16 sites, but fewer than 256 sites. And if you're thinking about that in terms of the 75% utilization threshold, then that's actually 12 sites or 192 sites. So if I have more than 12 sites and I get anything smaller than a /40, I don't have enough space to give myself a /48 per site. Maybe that's an issue, maybe it isn't. Depends on what those sites are. So when we obtain an allocation from a regional internet registry or an ISP, we've got some choices about what type of allocation that we're going to get. And for enterprises, this can be another area where they sort of fall into the tar pit and based on not really having the opportunity to get IP resources directly from a regional internet registry, which is difficult to do in IPv4, much easier to do in IPv6. So most of the REERs have, especially in RIPE and Aaron and APNIC have RIPE and Aaron in particular have made it easier for enterprises to get end user allocations, PI space, provider independent space, so that if I change providers, I don't have to number out of the block that I've gotten from an ISP, say, where I got a provider assigned address block. I can actually keep that PI space, number into it, and then I never have to renumber again, potentially, unless I do some really silly things down the road. So, if you're a small enterprise, you have one site, you like your ISP, and you're not going to plan on moving, then maybe you're perfectly happy getting provider assigned space, and that's the role that it plays. It's actually one of the few instances where we think that maybe NAT might be an appropriate solution if you have a single /48 site with a PA allocation. You want to change providers, you want to do NAT PT at the edge, and have a private range internally and a public range externally. That way you don't have to renumber your internal site. But that's probably the only very limited case where that makes sense to use any sort of NAT. So then we get into within the site. So we talked about between sites, we've got this decision that we make about how big of an allocation that we're going to get, and then we get into what's going on within the site. And this is where the real power of making sure that you have enough bits. If you choose to assign a /48 per site, then you've got these basic levels of hierarchy within your site that you can use to assign to functions and locations, and it gives you a way of looking at your network operationally through your address plan in a consistent way, and you can do this across multiple sites through your whole organization and keep things very, very consistent, which is something that was very difficult to do in IPv4. But again, these are the numbers that we should really get comfortable with if we're not already. Just that 4-bit decimal expansion: 16, 256, 4096, and 65,536. So the idea here is that we're going to figure out what types of functions or locations we have within a particular site, and we're going to map them into these selections of groups of subnets based on how many we have of a particular thing and how much hierarchy and topology we want to institute within that site. And we might have a site that's relatively flat, a regional office or a small office, or potentially even data centers that can be flat from a layer 3 perspective without a lot of topology to consider. And in that case, maybe we're perfectly happy with just peeling off individual /64s out of a /48 and assigning them. But that's probably probably the exception and not the rule. I think for most enterprises, there is some sense that the network is broken up within a site based on, these days on security policy more than anything. And how can I take that security policy, the ACL policy that I have instantiated, and map that into an addressing plan that keeps things simple and easy to understand. So we get this legibility dividend by sticking to this nibble boundary, where as long as did that line up? See, I don't know, this never lines up right. This red box should be over here, outlining 0, 7, and 8 through F. So as long as I stick to a nibble boundary, every character in my network prefix is significant, and I know that as soon as I move away from that 4-bit boundary, basically I have to expand out that subnet in order to understand where that particular prefix lives in that block. So as long as I stick to that nibble boundary, it's always unambiguous, and I know if I look at a particular prefix, it represents a particular function or location in the network. That's incredibly powerful, and a good reason to try initially to stick to that nibble boundary. It doesn't mean that you have to, in all cases, stick to the nibble boundary. There may be instances, and again, depending on your IPAM system, how much that's integrated into your operational workflow, it may or may not be an issue. You may be perfectly happy with carving up the v6 space for a particular site off of the nibble boundary. When we talk about interface assignments in IPv6, this is going to help us understand how we're going to group those subnets together and use them on the network. And this is one of the things that has challenged a lot of network engineers and architects that are steeped in IPv4, right? Where if you're used to carving up an IPv4 subnet to use the minimum amount of space, and suddenly we get into IPv6, and there was a reason for a period of time that we would put a /127 on a point-to-point link because of security concerns, neighbor discovery, cache exhaustion attacks, that sort of thing. Those issues have been addressed by the router vendors at this point, so there's no reason not to put a /64 on a point-to-point link. Even when you were putting a /127 on a point-to-point link, configuring that, but still setting aside a /64. So this really gets to the heart of the anxiety around IPv4 thinking and wanting to subnet in order to conserve address space. Well, it's just not an issue in IPv6. The standard interface assignments, then, we can think about a site in terms of the number of interfaces we have, the most simple gradation that there is. And then in that case, depending on the topology within the site, maybe we're perfectly comfortable not having that much topology or hierarchy mapped within that particular site. Just a slight digression here. I don't know if has anybody, by show of hands, has anybody used IPv6 Gen, the Perl utility for subnetting. Ed raised his hand. This is really a slick little tool. It's actually not conformant with the RFC that says you should use lowercase characters, but you can pipe it through another Unix utility to make those characters all lowercase if that bothers you. In any case, it's a really handy tool for taking a block and subnetting it out and seeing where your subnet boundaries are. Freely available on google.com, IPv6 Gen. So now that we've got some basic principles around how we're going to look at putting together an IPv6 address plan, let's start with a sample allocation and walk through a sample network to really get some sense of what it's going to look like. And in this case, we're going to assign /48s to sites. So I'm going to make that decision up front that I'm not going to give any site less than a /48 of address space. And again, I'm not concerned about using too much IPv6 space. If I don't have enough /48s for my particular organization, I'll just go back to the regional internet registry or the ISP. And again, just not to beat the point to death, but this is sort of a radical idea for enterprise network folk. They're not really used to thinking about having such an abundant resource, and so it takes some time to get their mind around that fact that they're not going to be constrained in IPv6 in the same way that they were in IPv4. And they need to make sure, in this case, we're going to make sure we have enough /48s for future use. We're going to do inter-site planning. So, here's this basic breakdown of. Let's see what's next. Okay, a basic breakdown of what we're going to see within a site. Between sites. And in the case where we have fewer than 16 sites, we're going to go ahead and say, a /44 is going to be sufficient. In this case, we're doing some things here that I don't know if they're really standard. We're just sort of saying they are at this point. I don't know that there are a lot of address plans out there that have adopted this approach as the standard approach, but we go ahead and reserve that first available subnet. Just set it aside and don't use it. And there's a reason why typically this is maybe something that you want to consider doing. If you're dealing with the 0 subnet, it's not always clear unless you look at that CIDR value, what network you're talking about. Like because of the 0 expansion that happens in IPv6, I can compress those zeros and I can end up with a prefix that looks like it could be a /48. It could also be a /52 if I've compressed those zeros. So if I don't use that first subnet, that 0 subnet at all, then that ambiguity goes away, and that way I'm from an operational standpoint, because again, your network engineers, your operations folks should be looking at the CIDR mask in every case. But if you're busy troubleshooting an issue and you're switching back and forth between screens, and in one instance there's the CIDR mask and you know what it is, in another instance you just sort of gloss over it, and then all of a sudden you're not thinking about the right subnet anymore. So the way to avoid that from an operational perspective is just to hold that first 0 subnet in reserve. And then you can do the same thing with the last subnet, but that's more of an aesthetic choice than anything else. And then there's some debate about, like, say, an infrastructure subnet. If I want to, how big of a block do I need to number my routers and switches for my overall network? Obviously I could do it with 1 /64. I can make that one. And typically, depending on where you're doing your routing summarization, maybe you want more than one block. Maybe you're, doing some. In IPv4, you've had to do some network routing redistribution. Have different routing protocols handling different blocks of address space, and you don't want to drag too much of that with you into the IPv6 domain. You don't want to try to model exactly what you're doing from a routing standpoint in IPv6, what you're doing in IPv4 into IPv6. But you will need an infrastructure subnet to address your routers and switches. And right now, peel off a /48, say that that's for infrastructure, and then going forward, maybe you'll have infrastructure subnets within each site, and that's perfectly fine. But you can see that right away, with 16 possible subnets out of a /44, I have used 3, 1 for infrastructure, and I've reserved 2, and so I've really actually only got 13. And then if I'm thinking in terms of capacity planning and making sure that I have enough subnets for future expansion, and using the Aaron rule, then I don't want to. If I'm above a 75% utilization threshold, then I should just be jumping up to the next nibble boundary for the allocation that I want to get. So that would be to a /40, 256 /48s. So there's a huge jump there. And then, of course, to the next boundary, a /36, then you're talking about 4,096 sites. So let's look at a sample enterprise. This is the Omni Consumer Products company. That's so I heard a titter. Did somebody know that reference? Anybody know what the Omni Consumer Products company makes? What's that? Yeah, that's right, the ED 209, the Enforcement Droid 209. So 2 corporate campuses, 3 data centers, 5 regional offices, Miguel Ferrer toiling away in one of them. And I haven't provided a whole lot of detail here. We'll just assume that there's some sort of MPLS VPN cloud that's connecting these sites together, and that the corporate head end is happening at the new Detroit headquarters. So taking that same breakdown, then we see that I've just basically mapped my sites into this /44 and provided myself with enough /48s to address all the sites that I have, and I still have 3 sites available, and I've set aside an infrastructure subnet. So is that enough room for growth? I mean, maybe it is, maybe it isn't. I personally, if it were my network, I'd be like, man, I probably want to go ahead and jump up to a /40 at this point, if I can only add another 3 sites. But for the purposes of our example today, we'll just say that that's going to be good enough. So intra-site planning. Sites often share similar functions, even if their existing internal topology isn't uniform. So this is where it gets a little weird, right? So if we're talking about using a /48 per site, we've got different types of sites. We've got corporate campus, we've got a regional office, we've got a data center. The internal topology of these sites isn't going to be identical by any stretch. We might not even have an internal identical topology between 2 corporate campuses. IPv6 gives us the opportunity to try to make that topology more uniform, right? If we're running dual stack, we don't have to do exactly what we did in IPv4 and IPv6, and nor should we. I mean, there's the opportunity to do things from a protocol standpoint, from a configuration standpoint, to make things more consistent. So maybe you're always blocked down based on the actual physical infrastructure to some extent. So the idea here is not to get too persnickety about how you're going to think about your internal topology, and things don't have to be perfectly consistent from site to site, nor do they have to be perfectly diverse. You have some choices to make here, and that's the art of design, the art of address planning. But you should know going in that you do have this ability to really take advantage of this abundance of space. But to keep things simple, you try to give each site type a similar internal address plan. That's just the basic principle. And if you can stick to that, then you should be in pretty good shape. So here's our corporate campus example. Again, very simple, just for purposes of illustration. Site prefix assignment of the /48. We're using that first available /48 for our new Detroit headquarters. And I've got a DMZ here, and I could actually set aside a separate subnet for that DMZ. And depending on how you're thinking about what you're doing with the components in the network that are potentially external facing, and how much availability you need to have those directly facing the internet. Maybe if I have a data center hanging off of a headquarters site or a DMZ, maybe I want to set aside an additional /48. And we're going to see this is going to be a theme as we move into the brave new world of IPv6, where we can just peel off a /48 or a /64, depending on what we're trying to address, and just throw subnets at solving a particular topological configuration challenge by using an abundance of address space and not worrying too much about whether or not it's appropriate for the relative size of that entity. I shouldn't be any less comfortable with assigning a /48 to a DMZ than I am with assigning a /48 to the entire corporate headquarters. And that's, again, one of the challenging mental aspects of getting comfortable with IPv6 address planning. So in this case, I've got a straightforward sort of campus network with the data center, building A, management IT, building B, sales marketing, building C, accounting, and building D, engineering and lab. So this fake enterprise network that will now go ahead and walk through instantiating the hierarchy of an IPv6 address plan on. So one method for site prefix assignment, we work from the left to the right highest level of hierarchy to the lowest level. And basically, we're just figuring out what do we have in terms of functions or locations within the site? What's the most important, from the standpoint of our network architecture, what makes the most sense on how we've configured that particular site, how we've architected it, to take those entities within that site and map them into the IPv6 prefixes. So for a lot of sites these days, it's going to be security policy, right? We've got, and depending on the size of the site and depending on and not just security policy, but also QoS, right? So we know that in many instances we've done some pretty slick things in IPv4 where we do things with wildcard masking to peel off slivers of the network in order to enforce a particular QoS policy or particular security policy. We don't have the ability to do that sort of wildcard masking in IPv6, but we do have the ability to just basically assign these big containers of address space to particular functions or locations, whether it's QoS or security, or if we're doing summarization within a site, which of course is much less common these days. We can do it based on how those networks are defined in terms of summarization. So yeah, choosing groups of prefixes for a given level based on either ACL, security policy function, or routing summarization, location requirements. You could even do it around, again, this is a logical construct, right? I mean, it has implications in terms of how you're configuring your network, because this is going to show up in ACLs, it's going to show up in routing summarization, configuration entries on routers, that sort of thing. But it's still a logical construct at some level that then allows you to do things like, think about how your organization is mapped. And from a business logic standpoint, you could instantiate an IPv6 address plan from a business logic standpoint. I wouldn't recommend doing that. You still need to have flexibility that's based on what your network's actually going to look like today and tomorrow. But that's just to point out that there is some flexibility based on it being a logical construct. So if I start out with my /48, the first level I can have up to 16/52s for functions or locations. And again, the 16 is the actual boundary based on the bit math. If I'm thinking about capacity planning, maybe I want to change that number, lower that threshold. Maybe it's a 12 to stick to the 75% utilization rule. Did that slide build out all the way? Yeah. So in that instance, then I'm going to go ahead and say I've got these functions within the network that are related to what's probably going to be security policy according to this example. So I've got the management and IT department, sales and marketing, engineering, lab, and then the DMZ. I'm going to give each of them their own /52. And again, because we're sticking to the nibble boundary, we get this really cool legibility dividend where from now on going forward, if I see this prefix, I know that it's the lab. If I see this prefix, I know it's tied to engineering. I don't have to, you're still going to DNS things obviously, but that's pretty cool operationally. I mean, being an old school enterprise IT and service provider router geek, being able to actually just look at a prefix and know where something is a pretty handy thing when the shit hits the fan, as they say. So then from level 1, I've got some choices to make. I actually had those choices back here in this slide, right? Just based on this. Well, no, I didn't include that. So let's go forward here. So for level 2, for each /52 now that I have at level 1, I can have up to 16/56s for additional functions or locations, or 256/60s, or I can go straight to the interface level and give myself 4096/64s for interfaces. So it depends on what you have then. However you've defined that first level of hierarchy based on whatever that happens to be. What comes next? Is it VLANs? Is it interfaces? LAN interfaces? Is it additional buildings? Is it additional subdivisions within that particular department? And again, this could be tied to actual infrastructure and actual routing configuration, security policy. In this case, I'll say for each /52 then, a /56, and you can see that range there. So I've picked on, in this case, building A, IT management, and I've decided that, based on what my network looks like today within IPv4, I know that I have a wired, wireless, guest, voice over IP VLAN, and I'm going to go ahead and assign that a /56. So that, again, the legibility dividend, I know that it's building IT management because that 1 in this position right here, and then going forward, that next 1 always means the wired network, the 2 always means the wireless network, 3 means guest, etc. So potentially of great operational value. So from there, from level 2, for each /56 at level 2, I can have up to 16 /60s for additional functions or locations. Each /60 provides 16 /64s for interfaces, or I can jump right to the 256 /64 level for interfaces. So again, it just depends on what the network looks like and where I want to assign my subnets. So in this case, for each of the VLANs, then I just go ahead and jump to the interface level, and I give myself 256 /64s to number into those interfaces into those particular VLANs. And then you just repeat that process, right, for the rest of the network. Depending on what the sites are, depending on how much topology they have, how much of that topology you want to map into the address plan. Again, if it's a small site, maybe I'm perfectly comfortable just handing out the next /64. But you try to keep the plan as simple as possible, but no simpler, and make it consistent as possible, so that as you go forward, you can really make the address plan much more durable than you've had the opportunity to make an address plan in v4, where you're having to constantly think about renumbering because of the lack of bits that you have to expand. Even in the private space, this is a challenge. And then, of course, you've got the challenge of overlapping address space, acquisitions that happen, mergers that happen, and you've got to somehow now cobble together, several different 10-space networks that are operating in conjunction. And that goes away in v6, right? I mean, I've always got I can always throw a unique subnet at whatever the new network is and number into it. As long as I don't overthink this, I need to think about it just enough, but as long as I don't overthink it, I can be in really good shape. What did I forget? What have I forgotten? Perfect abs. I forgot about the perfect abs. You don't need 30 minutes for perfect abs. Perfect abs in 30 seconds. I like this topic of IPv6 address planning so much that I wrote a book about it. And my mom has already purchased 2 copies, so I consider it a smashing success. I was home for the holidays, and I had my 1 copy that O'Reilly had just sent me. It was the only copy that I had. And I went to visit my mom at my grandmother's house, and she's like, "Oh, that's your book." She's like, she just takes it from me and she puts it in her bag. I'm like, "Okay, sure, Mom, you can." She's gonna read it and really get a lot out of it. I was like, that was my only copy. I was going to show it off to everyone, back home, and whatever. She apologized when I talked to her the next time. She's like, "I didn't even think about that. I took your only copy." And it's like, yeah, well, thanks, Mom. Infoblox has a practice around IPv6. We try to keep it relatively vendor agnostic. Obviously, we're focused on DDI, and we can talk about that until we're blue in the face and you're blue in the face. But we have a lot of white paper, solution notes, videos, webinars, guides, blog posts. Scott Hogue has a blog post on DKIM today that you might want to check out. And I think that's all I had. Love to hear any questions. If there are any enterprises here that are doing anything with v6, I'd love to hear about it. You guys are way advanced. This is all basic stuff for you. Any questions?
Hi, I was curious, because you work for Infoblox, I'm from an enterprise, so what is your, what have you seen other enterprises doing? What is the degree of adoption in other enterprises? I guess that's my question.
Yeah, it's a great question. And I wish I had a better answer. I need more of that data. Working for Infoblox, I'm somewhat shamefaced that I don't have better information about what other enterprises are doing. And we see operational questions that bubble up that suggest that enterprises are along the path a certain distance related to IPv6 adoption. We're starting to see some operational questions around DHCPv6 that indicate that this is a tough environment to make work correctly. Dual stack DHCPv6 with IPv4. There's a lot of complexity there. But that suggests that enterprises, we've got a fair number of enterprises that are looking at internal adoption of IPv6, right? Because we've always sort of suggested that enterprises think of it in 3 phases. You need to train and plan first because it's the lowest cost, the lowest risk to your organization. Then potentially make your website available over IPv6. If you're using a CDN or a web hosting company, that's trivial if they support IPv6. Otherwise, you've got to plumb through IPv6 from a service provider and light up a segment in your DMZ with IPv6, potentially dual stack, make your web server, make sure your web server supports IPv6, that whole thing, and then serve your content. And then by the time you do that, you've had to put together a basic address plan. You've gotten some facility with IPv6 operations. You're fairly far along. So I think we have some sense that there are quite a few enterprises that have taken at least that step. But then, contrast that with like the federal space where there was the 2014 mandate for making turning IPv6 on internally. And there's nothing like that in the enterprise, the private sector enterprise world. So I think what we're seeing is a lot of enterprises are getting pretty nervous about the fact that IPv6 is already running on their network and they can't turn it off. And so they're like, well, how do we effectively manage that? And then as soon as they start to pull apart the answer to that question, they realize that, okay, we're gonna really need to tackle this in a serious way and understand what we need to know about the security aspects of it and see how DHCPv6 works and Slack works and all the auto addressing that they potentially get out of IPv6. So I hope that I can get a better answer for that question this year, from our install base, because we're seeing some activity, we're seeing some motion in the enterprise space, and it's exciting. But I don't know what it means yet, and I don't know. We do have some customers that are really far along, and they've adopted IPv6 significantly, both internally and externally. But they're very much the exception and not the rule. The last one of these, Wells Fargo gave a great presentation on their IPv6 adoption initiative. I think that's available in the archive, and you probably want to check that out because they did everything the right way, or at least as far as I know. Yes. Is there? Oh, Chip.
Hey.
One second.
Hey, Tom.
Hey, Chip.
So just based on your experience so far and your thoughts in general, because we still kind of trying to figure a few things out. But what's your preference when you look in terms of planning an address architecture? What's your preference in terms of where you prioritize information with respect to services versus location organization? It's a common debate, right? I mean,
right.
Everybody has different preferences. And you see policy first and organizational boundaries later, or the other way around.
Yeah, I think it's a great question, and I think it's a work in progress, right? I don't think we really know yet. All we can really do is throw the principles out there and say, this is how you can do it. Now go forth and, apply it to your own network and tell it to, figure out what works for you, and then we'll use that as an operational model going forward for other enterprises. And really, with this presentation, I wish I could get more into the weeds and the details about what's best to do for the average enterprise, whether to break things down in the address plan according to function or location. In general, I think I'm getting the sense that location's less significant because there's less summarization that happens internally within enterprises these days. Networks are flatter, there's more ability to maintain state across the entire network, and so that piece of it isn't maybe so compelling. But the security policy side of things, the QoS side of things, I don't run an enterprise network these days, and if I did, I'd probably have a better answer. And I'm trying to provide the guidelines, to maybe.
I know the mic went over there, so I'm going to try to. I kind of agree with you. I mean, it looks much more that as architects get a lot more involved into this space more than operations. Policy becomes a lot more important and valuable.
Yeah.
Across the board, enterprise, but inside.
Yeah, for those at home, Chip just said that he agrees with me on everything that I've said today. So we have another question over here.
I'm not exactly sure how to articulate this. I'm curious if you've seen anybody, with the collapsing of the addressing space, so the ::1, ::2, putting interesting servers, services on those addresses. I mean, have you seen any?
Yeah, I've definitely seen it, and I think we see it more in the honeymoon phase of discovering IPv6 and the hexadecimal characters and being like, oh, cool, dead beef. That's really, now I always know where that server is. From an operational standpoint, for the durability of the address plan going forward, I think you can paint yourself into a corner pretty quickly with that sort of thing. again, there's a trade-off, right? I mean, I want some visibility. I'd like to be able to map some functional visibility in the network with the address plan. I can do that for the first time in IPv6 in a really extensible and durable way. But then I can also go way too far, get way too crazy with it, and create all this granularity that doesn't scale, right? It's just operationally inflexible, and then I end up having to renumber and number into, so it depends on what the. It depends. Sorry, I wish I had a better answer, but yeah, I definitely see it, yeah.
Thank you very much for your talk this morning. My question is around provider-independent blocks. Mm-hmm. We're a global manufacturing company, large enterprise, 132 sites, and we're going through the process of trying to get a /32 right now. Mm-hmm. But you had an asterisk on there about out-of-region routing, and I'm curious what you would recommend, whether to go to AppNIC, RIPE, for regional blocks that then we would aggregate.
Yeah, I would get the blocks from RIPE and AppNIC just because they're relatively easy to get. If you're already getting a block from Aaron, if you're operating in those regions, you meet the policy requirements. Get the blocks and have them available. Right now, and I'm open to correction on this, and I hope there's some smart folks in the audience who are dealing with this. I know we have an Aaron presentation, and there may be additional information there. Right now, it looks like out-of-region announcements are going to be okay, at least for the short term. We're seeing some flexibility there in terms of what the rear policy and in terms of how the providers are doing it. I know from running my own global backbone at one point, or being involved in that process of running a global backbone, that there's always things get a little weird in Asia. There's you're smiling. Maybe you know this. The games that get played with smaller prefix announcements, inconsistent announcements through different providers, and trying to get peering to be consistent. So does that mean that there will be turbulence on the front of out-of-region announcements where maybe you have trouble with a provider not honoring say Aaron space, using Aaron space in Asia? I don't have a crystal ball. I don't know. So because of that, it's probably a good idea to get the address space and have it and be able to number into it if you have to, because it's potentially a Band-Aid, right? I have this block and this situation arises where I need to light something up and make it available, and I can do that quickly if I have the block lying around. Maybe I can do it quickly if I have a good ISP relationship and they've got some PA space they can hand me, so maybe that's less of an issue. But if it's my network, I want to have that space ready and available. And when I was building the V6 plan for Limelight, I got /32s from all the regional internet registries, but that was back before I think there was a sense that out-of-region announcements would be okay. I think they're okay for now. I think out-of-region announcements are probably okay. Ed.
It's a quick question. Yeah. Did you want to address quickly, because it wasn't a talking point? You don't? Okay, we're done. No, Anycast and also link local. So talking quickly about structurally how people do some mapping between link local and also for some of the multicast Anycast functions, whether there's any challenges there.
I thought I was getting off easy, and then you have to ask this incredibly technical question. What do you think people should do?
Well, I'm just sort of curious. I mean, it's we've debated this back and forth, right, about best practices for link local configurations. What in terms of
when you say best practices for link local configuration? Well, link local configuration just happens, right?
Right, it just happens. But do you want it to just happen? Like, is it always something that you want to just happen, or do you want to have?
Do I have a choice?
Yeah, you have a choice, right? On your routing interfaces, do you want to use prescribed
point-to-point links, link local with point-to-point links,
or even for loopback configurations, or for things like it's next hop, and you want to always have the same default gateway everywhere.
Yeah. So I don't run networks anymore. I went to work for a vendor, and I don't have a good answer. I wish I haven't played around with it enough to really have a sense. And maybe it sounds like you might.
Well, I have my opinions, but they're just
what are
useless
they?
Opinions.
Yeah. What?
No, I mean, I think operationally it becomes a really difficult problem about interesting things like WAN addressing, and when do you decide that where's that handoff between your WAN addressing space and your on-premises LAN addressing space, and then choosing how you're going to deal with. Does it make the most sense to use link local that has a router ID associated with it versus using the common same link local ID for all of your VLANs on a particular subnet, so that they're the same default gateway for all the devices components you move around. So it's just sort of a question. It's not something that's specific inside of a addressing plan. It's much more of it's a policy sort of thing.
Right.
So that everyone sort of has the same policy. But it's an interesting discussion because I've gone back and forth with several customers on what they're comfortable with.
Yeah, and are they agitating for that? Or are you encouraging them to go on that? Like for me, I would be like, that's too granular. That would be like I'm losing some potential flexibility there.
Yeah, I try and convince them that flexibility is probably better for them long terms, but some of them are really rigid about wanting to have those sort of controls, and then it gets down to the like programmatic controls. Like I want to be able to repeat the same thing over and over again. Well, dynamic addressing and link local addressing become problems in that sort of area. You have to go query it as opposed to prescribe what it is.
Yeah, and I think you've hit upon a larger issue that I sort of glossed over, and just DHCPv6 in operational environments, Slack and operational environments, how that's all going to interact, how we're going to effectively manage it in a dual stack environment, going to IPv6 only. There's a lot of work there left to be done. David.
Yeah, David Farmer. Remember, the stuff isn't written in stone yet.
Yeah, exactly.
We're writing it.
Yeah, exactly.
So what do you want it to be? Do you want to be able to use an errand block globally? People have to tell the rest of us what you want, and we have to agree to them.
Yeah, that's a great point.
So while you please be humble and don't think that your answer is the right answer for everybody, right, but also tell people what your answers are so that we can learn from each other, because that's how this is going to work.
Yeah, great comment. And thank goodness we have the flexibility that we didn't have before. So, all right. Owen.
Owen DeLong, Akamai. I do actually have some opinions in this area, and I'm going to go ahead and share them.
Who'd have thunk it?
These are my opinions. I think that when you're contemplating things like whether to use fixed link local addresses and put the same link local address everywhere, one should always, when building a network, consider what I like to refer to as the principle of least surprise. And that is, if you have a new person working in your company and they log into the router and start looking at stuff, have you done it in a way that is going to surprise them the least? And or when they make a change without fully understanding everything you've done, is the result they get going to be one that surprises them?
Yeah.
Avoiding those kinds of surprises will help you sleep many, many more nights than you will get to sleep if you create a lot of those surprises.
Yeah, it's a great point.
As such, I like to let link local do what link local does. If you want a fixed address that's, universal across everywhere, then use an interface address, use a ULA or use a global unicast address, whatever, but you can put the same suffix everywhere using GUA and it's not a problem. And so you can know your gateway is always : 1 and use that as your static default route and put it into VRRP or put it into the interface on the router if you've only got one router and you're not worried about that, or whatever. There are lots of ways to get addressing consistency using static addresses without creating the kinds of surprise you're going to get from having the same link local address on every interface on a router. Those get especially surprising when somebody manages to connect two of your VLANs to each other and nothing else conflicts but those two link local addresses do. You're just inviting catastrophe, in my opinion, to do things that people don't expect. And so keep that in mind.
Thanks, Owen. All right, that's it. Thanks so much for your attention.